Ladies and gentlemen, here we go with section 2.7. Okay, 2.6 was just a little bit more practice with solving right angle triangles using Sohcahtoa. Remember, the key is to figure out which side is which, right? Figure out which side is which, so that if you have a triangle like this, say, and we're looking at this angle, the very first thing you need to do is to identify that that is the hypotenuse, that is the opposite, and that that is the adjacent side. Okay, and then we use Sohcahtoa or Sohcahtoa to help us figure out either to find the side or to find the angle. Okay, now we need, since we're going to be solving problems, right, we need some strategies for solving problems. So we're going to start off by looking at some problem solving strategies. Now, many of you have issues understanding what the words mean or what the sentences are trying to say. So what you first of all have to do is read the question thoroughly, okay? You have to read it until you understand it. And if you don't understand it, then you need to discuss it until you do understand it, okay? That would be with your partner, with me, with yourself, whatever. Just figure out what the hell's going on. Don't assume that you know what they're asking until you read the whole question, okay? Next, I would suggest that you draw a picture and that you label it, okay, if you can. Now, if you need help drawing, say, a 3D object, I can help you, or someone else can help you. Draw your triangles or whatever it is bigger. Don't draw it tiny because you can't see it. You got to be able to put numbers in there when you label it, okay? One of the most important things is that you have to figure out what you're looking for, right? What are they asking you to find? You can't give them an answer if you don't know what they're looking for. Okay, these are just 3 strategies. There are probably a lot more, but these are the most important, okay? And hopefully as we go through these, if you give them a shot, you will develop some strategies of your own and make it work, okay? Picture, absolutely. Read the question, understand it, absolutely, and you got to know what you're looking for, okay? So a couple things we're going to cover here, first of all, or review anyways. I'd like you to remember the difference between the angle of elevation and the angle of depression, okay? They are all related to the horizon, okay? One of the common mistakes that people make is that they put the angle of depression often with the vertical. So you will make that mistake, and I will point it out to you. And hopefully you won't make that mistake again. We will look at some angle stuff today in class, and I'm going to show you a few things real quick here to remind you of the basic properties of angles, okay? And we're going to start that really soon, but I want you to remind you of the couple things that you've done up to now. Always remember that you can use Pythagoras. Always an option if you have 2 sides, okay, for a right angle triangle. And also the right angle trig that we've been doing, Sohcahtoa, all right? Now, this is a bunch of angle stuff that I wanted to talk to you about. Angle stuff. Okay, so first of all, complementary angles, okay? A complementary angle is this. You can see that this is 90 degrees, right? So if I have an angle in here that's, say, 30 degrees, well, you know that this one is 60 degrees. These are complementary, okay? They add up to 90. Now, supplementary angles, okay, so add to 90 degrees. Supplementary angles, let's say we got 2 lines that they're going in opposite directions. How big is this angle right here? Now, hopefully you understand that that's going to be 180 degrees because it's half a revolution. An entire revolution would be 360 degrees, right? So if you know that a straight line here has 180 degrees, okay, if you know a straight line has 180 degrees, and then I put one in here that has 60 degrees like this, you know right away that that one there has to be 120 degrees because they have to add to 180 degrees, okay? Now, opposite angles. Opposite angles are exactly that. They're opposite. They're made by 2 straight lines, okay? It's made by 2 straight lines. And what it basically tells you is that this angle, let's call it theta, is equal to that one. And it also states that this one is equal to this one. These are opposite each other. Anytime you have a pair of straight lines, It has two pairs of opposite angles. Okay, triangle sum. You know that they all add up to 180. So opposite angles are equal. Triangle angle sum is they add to 180. Okay, we've dealt with that a lot. One other thing, quadrilateral, triangle, 3 sides, quad, 4 sides. So any four-sided figure, it doesn't have to be a square or a rectangle, it can be any shape with 4 sides. Hopefully you can understand that these 4 angles add up to 360. Okay, so they add to 360, and we can explain that by looking at the fact that you can split any four-dimensional shape, or sorry, four-sided shape into 2 triangles. Okay, and each triangle is 180, 180, that gives you 360. Now this last one here is something that some of you may remember. Okay, first of all, you need to know what parallel lines are. Here's a parallel line, there's one line, I'm sorry, and here's another parallel line. Okay, the arrows indicate that they are parallel, and this line here is what they call a transversal. It transverses these. So hopefully you can see that we have opposite angles. So this one here is the same as that one there. And this one here is the same as that one there, right? Now if these lines are parallel, does it not make sense that this line here has exactly the same situation going on as this line here? So if that's 1 and that's 1, well, that's 1 and that's 1. If that's 2 and that's 2, that's 2 and that's 2. These all have funky names. Okay, these all have funky names. These are opposite each other. Okay, those are opposite pairs. These are what they call corresponding angles. Okay, because they're in the same kind of position, right? It's in the top left corner, top left corner. That's corresponding with that. That's corresponding with that. And that is corresponding with that. These, notice that these on the inside, that Z law, they're the same as well. So are these. And you've got all, so this is just something that you should have done by now. If you need more information, just Google this, parallel lines and a transversal, and it'll have a lot of information. If you want to come talk to me, I'd be happy to help you out as well. So that's a little bit of stuff here. Now let's look at the type of questions that you might get in this section here. Okay, so before we move on, let me just put a piece of paper on here, and I'm going to ask you this question right here. So triangles in the same plane. What that means is that they're in line with each other, okay? They lie right on top of each other so that it's in 2 dimensions basically, okay? So it would be like having a triangle on the same plane. 2 triangles are in the same plane. They're not a 3-dimensional kind of thing. It'll make more sense after we discuss it a little bit more. But read this question and see if you can make some sense out of it, right? So, from the top of a 27-meter tall building, well, let's draw the ground. Let's draw some ground here. 27 meters tall. So let's draw a 27-meter tall building. There you go, 27 meters. Okay, you're standing at the top here. You measure the angle of elevation to the top of an adjacent building. An adjacent building. Adjacent, we know, means beside. So I'm going to put another building beside it. There you go. The angle of elevation to the top. Now, if you're looking for angle of elevation, you need, first of all, you need a horizon. Okay, you need this horizontal line. So let's draw a horizontal line to the adjacent building. And now it says that the angle of elevation to the top of that building, right, is 27 degrees. And it says the angle of depression to the bottom of the same building, we'll go like this now because this is the bottom of that same building, is 35 degrees. Okay, so how tall is the adjacent building? You're looking for this height right here. Okay, now you can probably see that you have 2 triangles here, and you can find that x, and let's call this one y. You can find x and y probably. So what you might want to do is remove some of these things, see if you can find out, well, put some more information here. You got 27 tall building, you got this angle, you got this angle. Can this number go anywhere else? This number here is the height of the building, and if this is all horizontal, that means that this here has to be 27 as well, right? So you've got y is equal to 27 meters right away. What you're looking for is x. Well, if you're looking at this triangle right here, bang, 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 boom, where this is 27 degrees and that's x, you need one more piece of information, right? Well, let's look at this bottom triangle. Do you think that you could find another piece, another side? Would this side help me up here? Or would this side help me up here? Right? So we're actually going to look at this side. So let's take that one out now. Let's have a look here. If this is 35 degrees and this is 27, I want to find this side right here. Now, this is the angle, right? Let's think about which trig function we're going to use. All right? So, I don't know if you can see, is that 35? You can see that's 35. Okay, so now, opposite and adjacent would be tan. So tan of 35 is equal to the opposite over the adjacent. That's what I'm looking for. So the adjacent is 27 over tan 35, and that's what we do in our calculator. Okay, gonna make sure I'm in the right mode. Where am I mode? I'm in degrees. Okay, so I got 27 divided by tan 35, and you end up with 38.6. So 38.6. So that means that this here is 38.6 meters. So this is 38.6 meters. And now you can find the x, right? You've got this side and you've got that side. We're looking at this angle. Opposite adjacent ends up being tan again. Tan of 27 is x over 38.6. In this case, your x is on the top, so it becomes a little bit easier. You just have to multiply the two, right? Tan 27. So you end up with, let's have a look. Tan 27, I like to do my trig function first, times 38.6. Boom, you end up with 19.7 because I rounded off, right? 19.7. So that's 19.7. So here you have x is equal to 19.7. So height is equal to these two together. So that's 46.7 meters, 46.7 meters. And that is the height of the adjacent building. Okay? Now, these types of questions, there's lots of different ways that you can ask the same question. So they might be a little bit different when you do a similar question. You might have to find different sides. They might give you the distance between the buildings, and then you have to find the height of both buildings. Either way, it's exactly the same processes. You write down the question, you fill in, you label the diagrams, you take individual triangles and deal with them separately, and you work towards your final goal. Okay, so let's have a look at another one here. This is triangles in a different plane. So I photocopied this picture here because it's a lot easier to see. I won't be able to draw one this well. I wouldn't necessarily ask you to draw one either. I'll probably give it to you drawn, and then you have to figure it out. So if you read the question here, what we're looking for is a distance between these two people. Now, leaf, it says, is directly south. So this is south. Tannis is directly east. Hopefully you understand then that this is a 90-degree angle. And since this is probably vertical, that's also 90 degrees, and that's 90 degrees. So what we have is a lot of right angle triangles. I don't have a lot of information about this triangle down here, so I can't find anything until I fill in some gaps. Let's look at Leaf's situation, okay? Boom. This is the distance to the tower. That's the tower. This is Leaf, right? I've got the tower is 35, and I've got this as being 50 degrees, okay? And then I've got Tannis over here. So this is Tannis, boom, right? That's 70 degrees, and the tower is 35 meters tall. So what we're looking for is the distance between them. Now, this lower triangle here is completely empty. I need to find some information. So looking at these two triangles, hoping that you can see, you can find this x here, which would be that, and we can find this here, which is your y, right? So how do we deal with this one? Again, it ends up being tan. Oh my God. All we're doing is tan with these. It ends up being a very common one because we often measure the height and the distance along the ground. The hypotenuse is less, I wouldn't say it's less useful, but just tan is a very common one when we deal with these types of problems, okay? So now let's have a look. Tan of 50 is 35 over x. And in this case, it's tan of 70 is 35 over y. So in each of these cases, folks, it's pretty easy to find your x, right? 35 over tan 50, and in this case it's y is equal to 35 over tan 70. So let's do some math here again. 35 divided by tan 50. There we go. We get x is equal to 29.4. Let's round it off, right? And then here, we're going to go 35 divided by tan 70, and you get 12.7. So we now have, let's look at this triangle on the bottom, okay? Let me get another piece of paper here just so that I can write it out. So now we're looking at this triangle down at the bottom here. I've got this x as being 29.4. I've got this y as being 12.7. Well, let's write it down. Boom. I know that's 90 degrees, right? This triangle is that triangle. This here is 29.4. This here is 12.7, even though it doesn't look to scale, right? I'm looking for this distance here. Hopefully you can see that it's simple Pythagoras in this case, right? 29.4 squared plus 12.7 squared is equal to x squared. So what I'm going to do is 29.4 squared plus 12.7 squared equals this. So I've got x squared is equal to 1025.65. And the last step would be to take the square root of that, right? So I'm just going to go the square root of that number, and I get 32 meters. So that means that they are 32 meters apart. Okay, so this is 32 meters. Lots of questions, lots of different things that we need to remember. Hopefully you guys can put some of these together and have some success.